Hello everyone, my name is Mandy and I'm going to talk about eel migration to the Sargasso, remarkable high swimming efficiency and low energy cost. And at the beginning of previous century, Smith found that the smallest European eel are near to the Sargasso Sea and the large eel are near to the Europe coast, and there are no eggs or adult eels had been found in the Sargasso Sea. So this is the only evidence that the Sargasso Sea was their spawning ground. And to prove Schmidt's theory, it needs to meet three hypotheses. First, fasting eels must possess sufficient energy reserve for a 6,000 kilometer migration. Many researchers doubted that the fasting eels can finish the long trip, and also they thought that European eels are the offspring of American eels that they drift over from the other side. But it was being rejected because the DNA and enzyme analysis clearly distinguished two species. And the second hypothesis, mature European eels and fertilized eggs must be found in the Sargasso Sea, but so far there are no one caught a mature eels or found an egg in this area. And in fact, only 2 reports of silver eels caught in the open Atlantic, so it's being rejected too. And the third, eel larvae must be shown to migrate towards the European coast, but the scientists still puzzled by the large difference of the age and genetic makeup of the European eels. And for their migration, European eels migrate 5,000 to 6,000 kilometers from European coast to the Sargasso Sea to spawn. And to get there in 6 months, a mean swimming speed of 0.4 meters per second is required. And the eels, when they swim 6,000 kilometers to spawn, they use about 40% of their fat. So this suggested that they have enough energy to finish the trip. And a typical 80 centimeters female eels can finish the trip in about 180 days if they swim at a steady speed. And however, there are no direct proof that eels can keep swimming for these long days at such a low energetic cost. So the purpose of this study is to determine the energy cost of swimming over a complete 5,500 kilometer swim in the laboratory. There are 2 kinds of experiments. The first one is they use 30 European eels to finish the 5,500 kilometers migration in 173 days. It's a long-term test. And the second experiment is a 1-week short-term test. They use 5 European eels and 5 rainbow trouts for the test. And these 2 species are in a similar body size. And also all eels in this experiment are yellow eels that in non-migratory stage. They use the Blaska type flow tanks in the experiment. The tanks are 2 meters long and can hold 127 liters of water. And in the tank, water speed remains constant across the tube cross-section, and the ignorable work effects ensure the fish swim in a natural and and unblocked environments, and both species maintain a constant speed in the tank. And there are two analyses for energy consumption. The first one is oxygen uptake. They measure how much oxygen the eels use when they are swimming. And the second one is energy testing. They analyze the eel's body tissues before and after they swim. And so they can see how much fat or protein they lost. And here are the formula. And here are the experiment of oxygen consumption. In the first long-term test, the eels swim at 0.5 body length per second. This match their natural speed to reach the Sargasso Sea. And in the second experiment of short-term test, the eels swim at 0.5 body length per second, and rainbow trout swim at 0.7 body length per second. All the species swim at their optimal swimming speed. And for this graph is talking about oxygen consumption of the resting and swimming fasting yellow eels. For the diamond, it means the swimming eels which swim with the rainbow trout in the short term. And the circle one means the resting eels from the long-term test. And as you can see, the swimming eels swim 2.1 times more oxygen than the resting one. And both lines stay flat and steady. So you can see their oxygen use is only increased a tiny amount in the experiment. And for their body constitution of dry mass of female yellow eels, this table is talk about what happened in the eel's body when they finish the trip. Here you can see the ratios of fat, protein, and carbohydrate stayed almost the same even they lost their weight. And also the eel's body composition didn't change in the same proportion. So the eels can maintain their body constitution steady and low energy cost when they until the end of their trip. And here I'm going to explain the cost of transportation. To get this number, we take oxygen consumption rate multiplied by swimming hours to get the total energy, and calculate with the conversion factor to get the cost of transportation number. And here are two independent estimates for COT. And I'm going to talk about the most important results. To compare the total energy consumption and COT from the oxygen uptake of swimming eels and energy testing of the swimming eels. You can see, although these numbers are slightly different, they are in the same order of the magnitude. And from the swimming efficiency in experiment 2, the first oxygen consumption, you can see the trout consumed 3 times more oxygen than eels, and in the same distance. In same days, eels swim more farther than the rainbow trout. And for the COT, you can see the trout use 4 times more energy than the European eels. So it suggests that the eels are efficient species. And for their metabolic efficiency, the European eels are more efficient than the trout. And for the COT values, the trout have higher COT values, so the trouts need more energy than the eels to swim in the same distance. And the rainbow trout is used as a standard value, so the eels swim 4 to 6 times more efficiently than many other fish species. And for the conclusion, fasting European eels can swim to the Sargasso Sea with high swimming efficiency and low energy cost. It removed the objection from one of the Smith's theory. Fasting eels must possess sufficient energy reserves for a 6,000 kilometers migration. And the only evidence for this high efficiency comes from their metabolic energy cost. The result is from the experiment to that European eels use less energy and oxygen than the rainbow trouts. And finally, the result of the eels' remarkably high efficiency remains unknown. Thank you for your listening.